Here we go, guys. Lesson 13-1, solve systems by graphing. So what in the world are these systems of equations? Well, a system is just two or more linear equations. It's two equations that you can graph a line with, right? We did that with the walkathons. We did that with the functions, the slope-intercepts, the start-step number, however you want to call it. That's what they are. There's two of those equations. So in order to solve that means we have to get a solution. And well, the solution to that system of equations is just an ordered pair. It's a number, two numbers actually. The first is an x and the second is a y, and it makes both of the equations true. Now this sounds a little bit weird, so we're going to dive into an example right away of checking this. Now the two equations don't always look the same. That's okay. This is what we have to do when we have a solution to the system. Here's your ordered pair. They're saying, is this a solution to this system of equations right here? And you can see that the equations look a little weird than what we're used to seeing. That's okay. How do we know, is this a solution? Well, you replace the x and y in both equations, and then you solve. And both equations have to be true, not just one of them. So let's go do that right now. I'm literally going to walk you through how to tell, is this ordered pair a solution to this system of equations? The first number in this ordered pair is an x, and so in this first equation, wherever you see the x, you replace it with the 4, because that's what x is. Well, the second number is a y, so wherever you see the y, you would replace the y with, in this case, a 1. Now, what is the y doing to the 2? It's multiplying. So I'm going to put parentheses in this right here. So that way I can remember, oh yeah, the 1's got to be multiplying the 2. Okay. Now I'm going to go ahead and just bring down the equals 6 right here, but from this part right here, if you have a calculator, it's actually very, very quick and simple. So if we can type in 4 plus 2 times 1, so, this highlighted part right here, into our calculator, and we hit enter in our calculator, and if it tells us that it's 6, then what that means is that, hey, this ordered pair is a solution to this one equation. Okay, so we got to find out, does this ordered pair actually make this equation true? So the easiest way to do that is to pull out your calculator, and it does the order of operations. It'll do the multiplication first. 2 times 1 is 2, and 2 plus 4 is indeed 6. So yes, this is a solution, but for my people that are really, really, really struggling, this is how you can actually use your calculator and trust it. You would say 4 plus 2, and then times the 1 right there, and just hit enter. Hey, look, we got 6, the same thing that's right there. And so when this setup happens, you can put this in to the calculator here, and it actually equals this side number. Then you're like, yes, that means that this ordered pair, the 4, 1, is a solution. So I would put like a check mark right there to be like, yes, this ordered pair works for this one. But we have to do the same thing for this one right over here. X is 4. This is a minus, and if my y was a -1, I would put a -1 right beside it, but it's a +1 there. For this one, you could pull your calculator out and say 4 minus 1, does it equal the 3? But you know that, and so you're like, yeah, so does this ordered pair make both of these equations true? Yes, it sure does. Now, one other thing that you might want to do, though, is you might want to be like, hey, rewriting this left side became a 6, and 6 equals the right side, so that's one way we could do it. What's 4 minus 1? It's a 3, and we've got 3 on the other side, so it's when these two sides equal each other, then yes, the solution is there. Last thing we need to do is let's take a look at what happens if it's not the solution to the system. So here's our second problem. Is -1, 2, this ordered pair, a solution to this system of equations here, the two equations? So let's plug in the x value, -1. The 2 is multiplying the x, and x is -1, so that's the reason I've got it in parentheses here, so 2 times -1, plus the 5, and there's your y. And your y is 2, but the y is multiplying the 5. So we're going to put this in parentheses to let it show that this 2 is multiplying it. And it's all equal to 8 here. So what's the easiest way of doing it if you have access to a calculator? Well, you simply type this all into your calculator so it can handle the order of operations. It'll do the 2 multiplications and then it'll add them together. And if you get 8, then yes, this ordered pair is a solution to this one equation. So let's test it out. So I've typed it all in there. You can see I've got the multiplication in there and the adding, and we do get 8. So this left side is 8, and that's the same as that side. So yes, it's a solution for the first one. However, it still has to make sure that it solves this equation also. It can't just do one equation. If we're saying, is this solution to the entire system, you have to check both equations. Up here, the 4-1 made both of these true, so yes, that's a solution. If this one doesn't work for this equation, I'll say no, and it's that simple. So let's just plug it in. 3 times -1 minus 2 times +2. Do we get 5? No, we get -7, and we were hoping to get 5. So I'm going to take this -7 and write it right there to show that, hey, all of this, let me move that there, all of this became equal to -7, and it's not equal, so that's the reason I put a slash there, is not equal to 5. So how about we just put an X there, and then it's very simple to say that, yes, this ordered pair doesn't make both of these true, it's just one. So does this ordered pair make the entire system of equations true? No.